The goal system here is it's a gravity offload system, so its primary purpose is to try and simulate the environments that we'd see in space in terms of both the frictionless motion and also the inertia of systems as they transfer momentum from a docking satellite to a docked satellite.
In space, we don't have air resistance or gravity, so as soon as you push something away from you, it's just going to keep going. And we need to replicate that phenomenon here on Earth, and the rig behind me is trying to attempt to do that. So this rig will be used with satellite manufacturers and technology providers who are looking to provide rendezvous proximity operations and in-orbit servicing, assembly and manufacturing technologies into commercial use.
So the gravity offload system, there are similar systems out there. Our system is more focused on the interaction between two objects. So for example, this is the two satellites docking. It's more in terms of the relative motions of those two objects coming together, how they would interact with each other, and that's what we're looking into.
So the main people who will be using and interested in the outcomes that the rig will provide are going to be companies providing rendezvous proximity operations technologies. And then beyond just rendezvous proximity operations, we'll be looking at companies who are carrying out future assembly tasks in orbit, servicing tasks, refueling tasks, all of which need to be able to guarantee that they can make a positive connection with the target satellite and understand what happens when you don't make that positive connection.
So in terms of starting this project, we originally started with a feasibility study where we looked at the actual design and how it would work with the requirements from Satellite Applications Catapult. Upon completion of that, we then went into phase 2, which is the actual deployment of the system itself. So that's where we've completed the design, gone through obviously all the necessary design reviews and governance reviews that have meant that we're delivering a safe system up to a high degree of standard. And as a result, we have then been able to build the gravity offload system at our site in Birchwood.
So a key challenge of this project was obviously it's to do with the interaction of the two satellites coming together. So we have to both be able to accurately display the momentum transfer at very slow speeds. When the two satellites get to that final docking procedure, we're more looking at about 5 millimeters per second, very slow speed.
The other challenges that we've had have been around making sure that everything works succinctly and communicates properly within the system. And then I would say suppliers are making sure with the long lead times that we can acquire all of the bits of kit that we need to proceed with the project. So I think one of the main successes I would say from the project has been the way that the team has worked cohesively as a unit.
At Amentum, we have various engineers, project managers, and loads of expertise across the business, which meant that we could really pull together all of our knowledge and create a rig like this.
We've got a really good team on the project, lots of different disciplines working together, and everyone's done a really good job, so I'm proud of that.
So we as Amentum are skilled integrators of lots of high capabilities of technology, and we're interested in seeing where this idea goes next. We've got lots of heritage now in terms of gravity offload systems, building together with Satellite Applications Catapult to make the next future variant of this type of facility but on a much bigger scale.